Now, reasons for the difference in rates of different reactions. First one is, for a reaction to take place, the bonds of the reactants is to be cleaved. When a product is being formed, then the bonds of the products should be formed. Bond breaking, to break the bonds of the reactants, energy is involved, required. That is, bond breaking is endothermic reaction, and bond formation is exothermic reaction. And for the values of bond enthalpies of different bonds are different. That's why there is your difference in the rates of chemical reactions. Another one is the activation energy. Different reactions to take place, they have different activation energy. So these are the two reasons for differences in rates of chemical reactions. Now coming to rate of a chemical reaction. The rate of a chemical reaction is the speed with which the reaction takes place. The rate of a chemical reaction is the change in the concentration of any one of the reactants or products per unit time. That is, rate of a reaction is equal to change in the concentration, by total time taken for the change, Now, a rate of a chemical reaction can be calculated either in terms of reactant or in terms of a product. So, the rate of a chemical reaction or the reaction rate, the rate of a chemical reaction can be determined as either the rate of decrease in the concentration of a reactant or the rate of increase in the concentration of any of the product. So we can write it in this way. The reaction rate is equal to increase in concentration of a product by time taken, for the increase, or reaction rate can be equals to decrease in concentration of a reactant by time taken for the decrease. During a chemical reaction, a reactant is being consumed and a product is being formed. It means that during the reaction, the concentration of a reactant decreases and the concentration of a product increases. That's why there is, therefore, in terms of a product, there is increase in concentration of a product, and in terms of reactant, since there is a reactant being consumed, so there is a decrease in concentration. That's why decrease in concentration of a reactant. Let us consider a hypothetical reaction. Reactant A gives product P. This is your reactant and this is your product. Now, at time t1, let the concentration of A is your A1 and the concentration of B is your B2. At time t2, let the concentration of A is your A2 and the concentration of B is your B2. So since a reactant is being consumed during a chemical reaction, so then that is your molar concentration of A2 must be less than A1, and during a reaction a product is being formed, so there is an increase in the concentration of B. So here B2 is greater than B1. So reaction rate is change in the concentration of any of the either reactant or product divided by time taken for the change in the concentration. This A2 is always less than A1 and change in concentration is A2 minus A1, so it will be negative. But a reaction rate is always positive. So in terms of when reaction rate is expressed in terms of a reactant, a minus sign should be given in the formula to make the reaction rate positive. Reaction rate is equal to decrease in concentration of A by time taken for decrease. So here will be del, that is A2 minus A1. This is your change in concentration of A by T2 minus T1. Since A2 is less than A1, so the value will be negative, but the reaction rate is always positive. So here we have to give a minus sign so that the reaction rate will become positive. Another one is reaction rate in terms of B. Increase in concentration of B by time taken for increase. So we can write B2 minus B1 by T2 minus B1. Since B2 is greater than B1, so the value will become positive. But to make it clear that we have to put a sign. In terms of a reactant, we will put a minus sign, and in terms of a product, we have to give plus. So the same one can be written as minus del A by del T, and this one will be written as plus del V by del T. Is it clear? Oh, thank you.